Today we're doing a new experiment, new for us.
Holy crap. I got it.
The reaction of sodium with water is terribly well known. We've done it lots of times on our videos. You drop a piece of sodium into water, and because sodium is lighter than water, it skitters around on the surface and reacting, liberating hydrogen, and then sometimes the hydrogen catches fire, and in one of our videos exploded.
You can see the orange sodium flame.
And a piece of it hit the camera.
Oh, it's on your camera. Oh, it is too.
This time we want to react a small amount of water with an excess of sodium. And the way we've done it is to take a piece of sodium and put it in the bottom of a beaker and then drop drops of water from quite high up onto the block of sodium. So one drop after another. So what happened was that the first few drops hit the surface, and because it's hard, probably ran partly off, and a reaction started round the bottom of the lump of sodium. And you can see bubbles. And the bubbles are probably hydrogen coming off, because the reaction of water with sodium gives sodium hydroxide and hydrogen. Since there isn't very much water, there'll be a strong solution of sodium hydroxide, and that's unlikely to have boiled, because the alternative explanation is that these are bubbles of steam. And then, because the reaction produces heat, it appears that the sodium melted, but because it's quite a small piece, it just stayed as a glob of liquid sitting on the bottom of the beaker. Then when the last drop came down, it very conveniently hit the surface of the sodium more or less square.
Holy crap. I got it.
And because water is quite dense, it made a crater, as it were, a puddle where it hit the sodium. And then, because the water is denser than sodium, it settled inside the liquid sodium. Imagine you have liquid sodium, the melting point is 96 degrees Celsius or centigrade, however you like to say it, and which is very close to the boiling point of water. And of course it could have been hotter than 96 degrees, so when the water goes in, it may well be in an environment that is higher than its boiling point. But because the water is denser and has momentum, it will go down to the bottom, so it's completely surrounded by hot sodium, and the reaction starts. And if you look carefully, first of all, the reaction blows upwards, presumably going through the hole that the water's made going in. And you can see an orange colour, which is probably the colour of hot sodium vapour. A few frames later on, the reaction really gets going, and the pressure of gas, probably hydrogen, blows the whole thing apart. Because there's much less water than sodium, the liquid that comes out must be, not completely, but a large amount of it will be tiny droplets of metallic sodium. And as these droplets go through the air, some of them will react with the water vapour in the air, and some will react with the oxygen in the air, and there's a lot more oxygen than water. And you can see there are one or two pieces that come off in this direction that are glowing really very hot and orange. It just demonstrates that when you do an experiment in a new way, you see even quite a common reaction in a completely new light. Of course, to understand precisely what's going on, you'd have to do lots of different experiments, varying the amount of water, varying the temperature of the sodium, perhaps even putting a thermocouple into the sodium to measure the temperature. but it doesn't really matter. What does matter is you can see that even this reaction is more exciting than we thought. As you know, sodium is only the second of the alkali metals as you go down the group. And we were lucky enough when we were using the high-speed camera to also video potassium, rubidium and cesium. And in the next few weeks, you'll be able to see all of those. And some of those were even more exciting than sodium.